Hi everyone, welcome to this episode of Kybit Labs. In today's video we're going to be discussing current in electric circuits as energy carried through the circuit. Okay, so what we have here, we have looked at a simplified diagram of an electric circuit. Okay, we've talked recently about voltage as energy that's applied to a circuit. And so, looking at this example here, each of these red buttons that I have here, each of these red things, represents a negatively charged electron that's existing inside this exaggerated metal wire. Okay, and then over here we have our voltage. Okay, so voltage being like a pump in our electric circuit, and that it's the thing that provides a pushing force that applies energy to make these electrons move. That the higher the voltage is, the higher the energy that is applied to them at the start. That pushing force that makes them travel around the circuit. Now, what we're going to now talk about is current. Okay, so current, where we're relating to the electrons that flow through the circuit. Okay, so let's say that I start out with a particular voltage that's here. And so I've got a negative charge here that's going to be pushing this electron this way through the wire. So the direction of electron flow is going to go around this way. Okay, and so what's going to happen, that we get this pushing force that happens, and then it's going to push this next one, it's going to push, and we're going to continue to get this pushing effect until it travels all the way back around. Okay, so this voltage, now I realize that was pretty sedate, that was pretty gentle, but that's the kind of the idea, that we get this push. It's like a domino effect that travels all the way around. Now, one thing that I want you to notice then, what I did just then, this button here, this electron, did not go whoosh all the way around the circuit nice and fast. Okay, that's not how electricity works. That we get this situation where that the electrons kind of push their next door neighbor, like in a line of dominoes. That was quite a good analogy to think of for you. That that one domino only pushes the next one, and then that pushes the next one. That original domino doesn't travel all the way to the other end of the line. It's the energy that it carries, the energy that it is able to pass on or transmit to the next one is what keeps it going, but that individual domino doesn't move very far. And that's the case with this electron, is that this one moves only enough to kind of then start to push the next one, which then starts to push the next one, and so on, continuing all around the circuit. Okay, and so when we're thinking about current, which we give the symbol of I, capital I, as the shorthand for what current means, which we measure in units of amperes, or capital A, or amps for short, is the number of electrons flowing through the circuit per second. Okay, so it's actually like it's a speed, or it's kind of a number. It's a bit like frequency when we're thinking about waves, that the idea is that the more electrons there are traveling through the circuit in a given time period, the more energy that's actually able to be carried all the way through. Because then it's kind of like, okay, if these ones are pushing faster and faster, that each of these electrons has more and more energy, that then there is more energy that is able to be used by the circuit as it's going through. The more energy that's available to things that we might want to connect, like light bulbs and heaters and those sorts of things. Okay, so the bigger, and so the more electrons there are, the number of electrons equals greater current. Okay, so I've used shorthand over here just to keep it simple, because I don't have a lot of room to work with. Okay, so the more electrons there are flowing, the greater the current is. So you might want to write that down in words rather than in symbols, if that would be easier to understand. Okay, so, and that's then more energy that's carried in our circuit. Okay, so what you can see though is that we just talked about this idea that voltage is like a pump, and so that you can see that how hard this pushes is going to have very much an effect on how fast these electrons are able to actually move through, how many are going to move through per second, because of how hard that push is. And there is a relationship that's there. We call it Ohm's law, but we're not going to go into that right now, but it's just showing that they're not completely separate ideas. Okay, so the more that there is this push here, the more these more electrons are able to flow by having more energy traveling through. And then the idea is that then that energy can be used to do all sorts of different things. All right, thanks very much for watching. Bye for now.